Okay, Shanmugh, tell me some brief introduction about yourself.
Sir, my name is K. Shankar, and I'm from Andhra Pradesh, and I have studied my BTech in 2019, and I have um, I completed my MTech in 2023, and my favorite subjects are power electronics, machines, and power systems and networks.
Okay, so where did you do your BTech from?
GMR,
GMI Institute. Okay, and your MTech from?
NIT Andhra Pradesh,
Okay, so what was your subject in MTech? What was your specialization in?
power electronics and drives.
Drives. Okay, so you told me that your favorite subjects are power electronic machines and electrical networks. Since you did already a specialization in power electronics and drives, so I'll
Yes.
start with some questions from power electronics and we'll move through it. So
Okay.
what is the main difference between a power electronic device and any other electronic device? Why it is specially a power electronic device? What is the fundamental difference between them?
Fundamental difference between them is, sir, it can handle high voltage and high currents and use for high power applications.
And what about the other analog electronic devices?
They can handle less power and less voltage applications, sir.
And what in frequency point of view, which of the power electronic devices have high frequency or low frequency?
Sir, depends upon like no power BJT, MOSFET and SCR. Based on the minor, if you means we if you talk about minoric and majority carrier, so we can.
I
Uh,
mean, applications of these devices, you are telling me about the internally device frequencies, whether they are high speed or high frequency. I'm asking regarding the application of the power electronic devices, whether they are used in high frequency applications or low frequency applications.
the MOSFET actually they are mainly used in low frequency applications like inverters designing and SMPS. In terms of SMPS, we are using MOSFETs
What is an SMPS?
switching mode power supplies, which are used in inverters.
Okay, what is the requirement? Why do we need to switch more power supplies?
Actually, switching mode power supply used to eliminate the harmonic components which are present in the means we don't in the when you are connecting from AC to DC, there is some ripples in ripple content or filter. Ripples in that DC waveform. So what we are doing is we are for that ripples we need a high filter, large size filters. So what we are doing, we are converting that we are increasing the filter content means the magnitude by using SMPS, and we are using by this we are reducing the L and C values at the end of the filter side filters.
Okay. Can you tell me some examples of this switch mode power supply converters which are used in it?
So means internal design or what?
The names of those converters.
Flyback converter, forward converters, and I think resonant converters comes under zero sequence switching and zero voltage switching.
Which of these acts analogous to a buck boost converter?
Mm, buck boost converter, flyback converters. Sorry, forward converter.
Forward converter is a buck boost converter. And what is a flyback converter?
It is, I think, bug converters because I am not. Means by analyzing only I can tell.
Okay, then try to draw the circuit of a flyback converter and on and off analysis and let me
Okay.
know.
So,
Actually, I cannot see that. I think because it's masked, the background is masked, this is not visible. Uh, is it possible to post it in the chat?
try, sir. Yes, sir. Yes.
You can just switch off that blur. Shanmuka, you can just switch off that blur part.
Okay, sir.
Don't blur the camera. No, it's not visible. It is blurred.
No, sir.
Yes, this is fine. Okay. Now tell me, do the analysis and tell me how is it working as a buck converter or a buck boost converter?
Okay, sir.
You did not write the equations.
Okay, sir.
Can you just tell me by doing the analysis?
So first, if I have a switch here, now inductor stores energy. When I open the switch, uh, due to the magnetic coupling, there will be some voltage induced in this because it is a transformer. Some EMF will be induced. But thing is that uh, the current has to go, means as per a transformer principle, the current has to come from, means leave the dot. When the current is entering the dot, in the secondary it has to leave the dot. But the diode will not allow it. For that reason, at this time, what is the flux developed in the transformer, it tries to reduce. To avoid this, what will happen? The inductor start current, delivering the current in the reverse direction such that the diode will on. So here, what I feel that the it is working like a buck boost converter, I think,
Yeah,
because
you
the polarity.
think are you sure about it?
I am sure, sir, it's buck
You are
boost
sure
converter.
that it is a buck boost converter?
అక్క ముందు
Are you sure that it's a buck boost converter? Hello?
Yes, sir.
Are you sure that it is a buck boost converter?
Sir, I can, but it is releasing. Yes, sir,
Okay.
ma'am.
So, regarding this, can you tell me what is the maximum voltage that can come across the switch?
Switch, sir. VDC, VDC plus V naught, sir.
You know, where is the transformation factor? Did you
Sir,
estimate transformation factor of the
because,
transformer?
sir, in many of the cases we are in like no pulse transform we are taking 1:1 ratio.
You are taking one. You have, if suppose I say that the transformation ratio of the transformer is 1 is to some A,
Okay, sir.
then what will be the voltage that will be appearing across the switch?
Okay. It is AVDC plus V naught, sir.
If VDC is the voltage that you have connected at the load side, right?
Yes, sir.
Okay. Okay, then you can come back to the camera mode. I mean, show your face. Okay, so can you tell me what is a resonant converter?
Sir, resonant converters are mainly like it is a LC oscillator type, which are used for creating a zero current point when the switch is on, and zero voltage point when switch is off. Sorry, we have to turn on the switch by creating zero voltage across the switch.
Yeah, but what is the main requirement? Why do we require resonant converters?
Sir, as we are, as the principle is that we have to reduce switching losses with respect to the device which are using.
Okay. What is the fundamental difference between a voltage source inverter and a current source inverter?
Fundamentals are voltage then the current source. Fundamental difference means with respect to the cycle diagram or the number the types of the in the voltage source and the output voltage is constant irrespective of what are the load we are using. In current source inverter, the current is constant irrespective of what is the load we are using. Conditions apply that the load that connects to should not be the opposite load. If you are using voltage load, if you are connecting the
Okay. So let me ask a question related to the phase control rectifiers.
okay,
So in case of is first of all called a phase control why the power electronic rectifiers are called as phase control rectifiers?
phase control rectifiers.
Okay, so leave about it. Since you have mentioned your second favorite subject as an electrical machines
Yes,
or power systems, what was it?
machines.
Machines. Okay, so tell me the main similarities between an induction motor and a transformer.
Sir, so the construct stator endings uh, uh, the rules the what is the rules we have quoted like Faraday's law and
Okay, can you tell me? Okay, that's okay. Can you
the
tell me the application of an induction generator?
application of induction generator. Sir,
Why are not okay? Can you tell me why induction generators are not very popularly used?
because we should for induction generator we should separately supply means require it as variable capacitor for supplying of reactive power.
Okay, okay, fine. So can you tell me mm, In case of a DC machines
Yes.
and in case of an induction machines, for a particular application, like if you want to run some kind of an internal household appliance, which one would
Yes.
you prefer, an induction machine or a DC machine?
So we will prefer induction machine because for DC machine we have to means uh, the maintenance purpose of DC machine is more when compared to AC machines.
And what is it in the harmonics or frequency point of view? Fluctuations or harmonics?
In harmonics point of view, DC machine have no such means such means when we are using our sports in harmonic point, DC machine have no just such much effect, but induction machine will have effects.
Okay. So, in what, which kind of machines are more popular in the power electronic drives applications? You have done your specialization in drives, right? So it's a
Yes, sir.
combination of your power electronics and the machines.
Yes,
So
sir.
in your during while you were studying regarding the drives, which
Yes, sir.
machines did you find more popular in?
I find synchronous machines.
Synchronous machines are used more for the drives applications.
Yes, sir.
Okay. What is short circuit ratio in synchronous machines point of view?
Short circuit ratio, it is a field current that is means field current that is required to means ratio of the field current that is required to produce a rated voltage to the field current that is required to produce short circuit current.
Okay. What is the importance of a short circuit ratio? Why do we need this factor and what is its importance?
Mainly, it tells about the stability. Means if the short circuit ratio is means short circuit ratio is less means armature reactance will be more as it is inversely proportional to the that is synchronous reactance. So from that armature reaction, if armature reaction is less, then the coupling between the magnetic field will be more and the stability will be more. So in the synchronous point of view, we can know stability if SCR is more.
Okay. Can you tell me the axis on which an inverted V curve is plotted?
So inverter.
V curve, between which parameters do we plot an inverted V curve?
Okay, in synchronous machine. Okay, okay.
Yes, in
Uh,
synchronous machines.
Inverted V curve means we are getting unity power factor at maximum value means it is drawn between armature power factor versus field current.
An inverted curve is drawn between power factor versus field current. Are you sure?
Yes, sir.
And you mean to say that the power factor will be minimum at one point and it is going to increase in case of an inverted V curve.
Sir, inverted V curve means this no, sir.
And what about a V curve?
V curve means at minimum value at the unity power factor means it will be armature currents versus field current.
Okay. So one more last question. You have completed your B Tech in 19 and you have completed your M Tech in 23. So
Yes, sir.
what were you doing between 19 and 21?
Sir, I start means in that in the 2 years I gone for IES study for preparation of IES.
You were preparing for engineering service exam. Did you clear any levels?
Prelims skills, analytical means, advanced qualified means.
Okay. Okay. Okay then. We'll end up this and that's it. You can leave actually.
Okay, sir.
Oh,
Thank you.
Sir, you can provide him feedback.
okay. So right now.
Okay, sir. I'm writing.
Okay. No, I'm asking.
Yes, sir.
अभी
Yes, sir.
बताने क्या इनको?
इनको अभी बता दीजिए ना फीडबैक तुरंत ही.
अच्छा. सो जैसे कि आपने एमटेक कर रखे हैं तो आपको जो क्वेश्चंस है वो तो मैक्सिमम यू आर नॉट कंफर्टेबल इन हिंदी राइट?
Yes, sir. I'm in Hindi, English only.
English only. So I was saying that since you have completed your MTech in power electronics and drives, So more
sir.
questions will be, I didn't ask you about your thesis as well. Some questions may come from thesis also. It depends upon how you interview went in that way, and then related to the harmonics, I asked about the resonant converter. So it depends upon what words you use. And
Okay.
one more thing, so yeah, more questions will come from power electronics and drive, since you have already completed an MTech. If you are just
Okay.
BTech, then questions can come from anywhere. Study more
Okay.
about your projects, and
Yes,
in
sir.
further mocks you will be asked about the projects. And this is an introductory, so we started with the basic questions only.
Okay, sir.
Be well versed with the circuits, at least in the power electronic point of view, power
Okay.
electronics and drives point of view. And one more thing is, look at the camera while answering the questions. You were looking away from the camera. Try to
Okay.
look at the camera or to the person who is asking you questions. And also, don't stumble. I mean, it comes with the amount of confidence you have. Actually, I think you are a bit scared about giving an interview. It gives such an impression. But what I have observed is that your fundamentals are clear, that I have understood, but you are not able to express them in a proper way. Whatever you are told, maximum of the answers were correct. There were some few wrong answers as well, but yeah, mostly fundamentally your answers were correct, especially when it comes to power electronics point of view. But I would say that don't use the words like I think or this may be. The instead try to be more confident and don't stumble like give the answer in a proper single statement that you'll be getting in practice. Try to tell the derivation, use the word. You are coming to the point, but it is taking some yeah. Next time be ready with your projects as well along. Yeah, I also prepare mainly graphs and all. I didn't ask much graphs this time. Prepare with
Yes.
graph point also. But for you, I would say that power electronics will be immediate shooting factor for them.
So,
Okay.
thank you.
That's it from my side. You can do much better. I can see that your fundamentals are clear. So I have, you can do much better. Okay.
Okay.
So the level of interviews in the next mock interviews, that is also going to increase. We'll go in much deep. So this was a preliminary one. So
Okay.
try to practice more and keep the feedback in mind that I have given. Okay.
Okay.